Hey everyone, welcome back to science class. We are finally done ecology and we're moving on to chemistry. Chemistry is an awesome unit. We get to do tons of experiments. Wait, no, we don't. We don't get to really do experiments because we're not at school. But we still got to learn really cool things and it's going to be fun. It is a really cool unit, especially when we get to do experiments. Hopefully we get to go back to school and do something, but we'll see. We're still going to learn some really cool stuff. We're going to start with review, which is on Bohr diagrams. So you've got this assignment called Bohr diagram work. And so what we're going to do with it is review how to make Bohr diagrams. I'm going to show you here how to make a couple, and then you're going to just fill in the rest of these today. Tomorrow or next class, we'll do a bit more on this stuff. You really have to have the fundamentals of how a Bohr diagram works and looks before you can move on with the rest of this unit. If you can get this stuff, this is foundational, the rest builds off this. And so this unit in particular, this unit builds as we keep going. So you really want to keep up. You really want to know what's happening at the foundational stuff where we start, and it just builds off of what we do at the beginning, all right? And so we start off with Bohr diagrams. They are important. Some people might argue, hey, Bohr diagrams aren't actually exactly how atoms work. Physicists have proven that electrons don't actually orbit a nucleus. There's these electron clouds, right? Yes, that's true. But Bohr diagrams still really show us how electrons behave. And so there are energy levels with electrons, and there are certain number of electrons at each energy level. And so that's what Bohr diagrams help us to see. There is such a thing as valence. We'll talk about the word valence, and that does literally exist, and that does define how elements are going to react and bond. And we're going to get to chemical reactions in this unit. And so we need to understand how the Bohr diagram looks. Even though it's not totally proper, it does do a really good job of explaining how different elements interact. So you need two things for this assignment. You need this document open in this program called CAMI. CAMI is a program that allows you to edit documents that I give you on your computer. I think it's really handy. Mine says the trial ends in 8 days, and so if we stop using it in 8 days, that's unfortunate. Hopefully we can keep using it. I'll ask whatever, I'll deal with it. If we can't use it, we can't use it. But for 8 days, for sure, we can use this program. What we can do is edit on the document. And so I'm going to show you how to use this to fill in these Bohr diagrams. And then you can turn it in on Google Classroom. So you should have clicked edit with CAMI, and then you'll turn in. And then I can see all the edits that you made. You don't have to print it off. So hopefully this is a very handy tool for this. The other thing that you need is the periodic table that I shared with you on Google Classroom as well. So you need one of these. And we're going to go over what this means, how to read it, and go on from there. So here we go. How to make a Bohr diagram. This should be review, and how to use CAMI in the meantime. So we're going to make a Bohr diagram starting with calcium. Okay, so the title's on the side here, and we're going to make this into a Bohr diagram of calcium. So first thing we need to do is find calcium on the periodic table. Okay, and there it is. It is number 20. We're right here at calcium. Okay, the letter is Ca. The atomic number is up top, and so if you're not sure, right here, this is the descriptor up top here. It's atomic number, and then the symbol, atomic symbol, and then the name, and then the weight of it. Those are the 4 pieces of information that each cell gives you. First, the atomic number of 20, and Ca, which is calcium, and the weight of 40. Okay, I want to remind you, the atomic number of 20 is the number of protons. Okay, protons. We will go over this more in detail. This is a bit review, but protons is where we start. Okay, the protons is how each element is defined. If you were able to change the number of protons, which is very difficult to do, not impossible, but almost, to change the number of protons in calcium, to steal one away, you would no longer have calcium, you would have potassium if you stole one proton away. Not only would you have potassium, but that one proton you took away, what is that? It's actually hydrogen. You stole a proton, you created one hydrogen atom and one potassium atom. And if you were able to combine a hydrogen and potassium, just slam those two together, you would have they're gone. Now you have calcium. So a element is defined by the number of protons. And so we look here, and we want to make this into a calcium Bohr diagram. So what I'm going to do is I'm going to go to text, okay, on the left side. And I'm going to click inside here. I'm going to change my size to something that seems fitting. Let's try, what are we at, 60? Let's try 30. I'm going to write Ca. Those are the letters for potassium. Sorry, for calcium, not potassium. All right, so we need to define this as calcium. We need to say one other thing. So I'm going to do another text box up here. And I'm going to make this a little bit smaller. Let's make this 18. And we need to write the number of protons. So P equals 20. There are 20 protons. And let's do another one. And we also need to write the number of neutrons. Now, how do we get the number of neutrons? I'll write a text box here just for your notes. Number of neutrons is the atomic mass minus the atomic number, okay, which is the number of protons. All right, and so in this case, the atomic mass, we go here, and we see the atomic mass is 40, and the number of protons is 20 for calcium, 40. We always round, okay, 40.0 is just 40. This would be 44.9 scandium, so that'd be 45. So just for reference sake, 47.86, that rounds up to 48. Where's one? And this one rounds down, right? 39.0 would round down, so this would also be 39. This is calcium, though, is the one we're looking at, 40.0, that's 40. And so 40 atomic mass minus atomic number of 20, and we get neutrons of also 20. So it's not always the same. Okay, for example, calcium is not. 39 minus 19 would be 20. Potassium also has 20 neutrons, but we're not doing potassium. Calcium has 20. We're done the nucleus, okay? And so this is a good start. This is what we need to do inside the middle circle. Calcium has 20 protons and 20 neutrons. This is what the nucleus is made of. So this is lesson 1. The nucleus of an atom is a small center part that has protons and neutrons. And it also has electrons that exist on the outer rings. So how do we put in electrons? I'm going to go to the left and go to drawing. And I'm going to draw thick strokes. 12 is probably good. Red dots. Okay. We have to put electrons on these rings. Okay. The first ring has 2. Okay. I'll make a little note here. Electron rings. Two electrons. Second ring can have up to 8 electrons. The third ring can have up to 8 electrons again for now, and on and on. And the other ones don't matter for us this year, okay? This is what you need to know. Electron rings, the first ring can have up to 2, the second ring can have up to 8, the third ring can have up to 8, and the fourth ring will have the rest. We're only going to go up to 20 this year, okay? And so what we're going to do is put the first ring can have 1, 2. This is how I want you to do them, 1, 2. This is a full shell now, okay? This is full, and it's happy. But we need 20 electrons. We need the number of electrons to balance the number of protons so that they have a net charge of 0. So we know that protons have a positive charge and electrons have a negative charge. And so we've got right now 18 extra protons because we've got 2 electrons and 20 protons. So this is not balanced. So we need more. So we start to add up top. We need 3, 4, 5, 6, 7, 8, 9, 10. So here we're at a point where we have added all 8 on the second ring. So the second ring can have 8 electrons. We've added 8 of them, but we're still not at 20. We're at 10. Okay, you get used to this number because by the time you're done the second row, you should always be at 10. Okay, interestingly enough, look at that. Neon is at 10. Once you're done the first row, you're at 2. Once you're done the second row, you're at 10. Once you're done the third row, you should be at 18. So let's keep going. We're at 10. We can't put any more on the first because we're at the 2. We can't put any more on the second row because we're at 8 on that ring. Total 10. So let's go to the third ring. Notice the order I did. I started here, 2, 3, 4, 5, 6, 7, 8. I always want you to follow that order. Okay? Start at 12 o'clock noon with your first one. Do your second one at 3 o'clock. 6 o'clock for your fourth one. 9 o'clock. And then fill in the pairs. Okay? So that's 5, 6, 7, 8. Okay, here we are. We have done a total of 2 plus 8 is 10 plus another 8 is 18 electrons. We need 20. We're still not there. So this one doesn't even have enough rings. So what I'm going to do is I'm going to add, you don't need to add another shape. I'm just going to add 2 more electrons because I need 2 more. Okay, 1, 2. Now these are on the next ring that would exist there. I guess we could do another shape and just do insert a circle. That's blue. But this is going to be a ton of work. That wasn't that bad. There, so we could do that. This is what it should look like, okay? This is what it should look like. We've got 20 electrons, and we've got 20 protons and 20 neutrons, and it's calcium. This is very clear. This is a Bohr diagram for the element calcium, okay? I really want to stress, you need to have the 2 dots on the outside. Okay, so it's 2, and then 8, and then 8, and then whatever's left. Okay, and it's always up to 8. We'll see that in the next one. And then whatever's left. But in this case, these 2 need to be one up here and the next one down there. I don't want to see them both together up here. Okay, follow the pattern that I'm demonstrating here. So let's do one more element. We're doing nitrogen, and then the rest you'll get to do by yourself. Lucky people. So we're going to start with nitrogen is the letter N. Okay, so we start with nitrogen. And then I'm going to change the font size again. And whoops, didn't mean to do it to that one. Do another text box. That will be 16. The protons. How many protons are there in nitrogen? Well, let's go. Let's look. Nitrogen right there is number 7. Okay, which means it's 7 because there's 7 protons. Does that mean there's 7 neutrons? Not necessarily. How many neutrons are there? We have to look. The mass is 14. And so the mass is made up of protons plus neutrons, okay? Because a proton weighs 1, a neutron weighs 1, and so if you've got 7 protons and 7 neutrons, you've got a total of 14. And that's what we got. Electrons don't really weigh anything of any significance. There we go. Our nucleus is good. We have done it. 7 protons and the remainder of 7 neutrons, which gives us a total mass. We can just look. The total mass must be 14, which it is. And now we'd have to do 7 electrons to finish it off. So we go back to our drawing tools, and we start. We need to get to 7. So we go 1, 2. 2 electrons on the first shell. Then we move to the next cell. Shell 3, 4. Notice the pattern. 5, 6. And then we start to double up. 7. Now we're done. We're at 7 electrons. That matches our 7 protons. That's it. We are done. This is the Bohr diagram for nitrogen. That's it. Okay, your job is to keep it going. Do neon, do silicon. Hopefully you get used to this tool called Cami, and it should be pretty slick, pretty smooth, and then you can turn it in, and I'll put up a key very soon, and you can check your work and make sure that you're doing it right. I really want to see all 3 pieces of information in the middle being correct, okay? The letter, which is pretty clear. I put it right there for you, right? I want to see the number of protons and the number of neutrons, which you find by looking at the periodic table. And then I want to see a matching number of electrons as the number of protons, with 2 on the first, up to 8 on the second, up to 10, up to 8 on the last, on the third one, and then whatever's remaining outside. All right, if you have questions, email me and have some fun. See you later.